long period of time in a dry air filled condition or nitrogen filled condition, but there was some leakage or some issue with that transformer, this gas system. So now moisture may have penetrated deep down. Once we do the commissioning of this transformer, it is possible we are not able to measure the moisture which is present there. So here we can use FDS to assess the integrity of our paper. So besides this, temperature and moisture dependency on life of transformer is also being studied, where transformer life expectancy based on the temperature on which it is operating and the condition, the moisture present inside the paper. We can use all this mechanism to assess how long our paper can last. As per various standards available, every rise of 6 degrees Celsius in paper will accelerate the aging of that paper by 2 times the number. So we have to maintain our equipment at an optimal temperature. Cooling is to be devised accordingly. This is a big challenge, especially for our renewable transformer, where our equipment is operating almost close to full load continuously, and at other times it is operating almost on no load. So on such cases, it is very critical to monitor the temperature of the unit to estimate what is the life expectancy. Power Grid has also adopted variable frequency tan delta of bushing. We are using it in the range of 15 to 400 multiples of 17 except 51 Hertz. Here again we have seen that bushing which is more critical will have, if for example it has got some moisture inside or there is some fault inside, then vulnerabilities are more prevalent or more prominent in the lower frequency range. Especially we have seen such cases where equipment tan delta at 50 Hertz is almost normal or very close to normal, as you can see in this graph also. Our 50 Hertz frequency tan delta is almost close to the healthy bushing tan delta value, but at lower frequency 15 Hertz, it is having a very appreciable rise. So when we did the DG analysis of this OIP type bushing, then we found a lot of gas was there. It was hydrogen was almost 41,000 ppm. So there was a lot of partial discharge occurring inside that bushing, and it could have exploded at any time. So by doing this variable frequency tan delta of the bushing, we have been able to prevent one of the failure of our transformer. Talking about bushings, we have also adopted RIP and RIS bushing. Power Grid has already adopted it since 2015. Now nearly 4,000 RIP, RIS bushings are in service across Power Grid network. Globally, you can see number of transformer failure which are caused by bushings is ranging from 15% to up to 50% also. This has been quantified by various studies. Even at Power Grid also, our failure rate earlier was almost 38% when we had a lot of OIP bushings. So that is why Power Grid decided to transition from OIP to RIP or RIS type bushings from 2015 onwards. And CE has also now mandated the use of RIP bushings in 400 kV equipments. And we are very happy to say also that India as on date is Atmanirbhar in terms of RIP bushing manufacturing, because now up to 400 kV level bushings are being manufactured in India, and we have got a number of manufacturers available who are manufacturing it. So there is no dearth of issue of importing or getting this technology from abroad. Besides this, we have also implemented an RCM framework where health indexing, degradation and impact of failure is assessed, and a quantified maintenance plan is created for each and every one of the unit. See, every unit cannot be equal. Every unit will, the health of the equipment will vary. The criticality of a unit from the point of view of the network will also vary. So whenever these two things are taken into comparison, we have to design or customize an individual AMP plan for each and every one of our equipment. If my equipment is critical but not severe, then it would require a different kind of a maintenance plan. If it is severe but not critical, it would require a different kind of AMP plan. So this all permutation and combinations are being done in almost real time, and each and every equipment has its own unique reliability plan which is being created. So this is also something that Power Grid has now implemented, and by implementation of this RCM framework, we have been able to reduce the workload of maintenance requirement or loss of availability by nearly 37%. Now, I would talk about the impact of all these latest intensive monitoring techniques and mechanisms that we have adopted. So you can see our failure rate of transformer reactors has been going down continuously. In 2012, it was around 1.44%, and internationally benchmark is said to be 1%, where we talk about 1% failure rate is considered as acceptable for all utilities. Now Power Grid has a failure rate of 0.55%, and this number of 0.55% also has, it may appear to be very low, but it is further lower because we have to also consider that a lot of failures occurred in around 2012 to 2015, which was due to failure of bushings. And since now we have adopted RIP bushings, so such kind of failures are not likely to occur. So another source of failure has been addressed. So now if we talk about the last 5-year window, our failure rate would be even less than 0.3%.
Hello.
Now, before I conclude this session, I would just briefly touch upon the future of transformer from asset management perspective. The future of transformer involves artificial intelligence, a digital framework, and a smart transformer. Smart transformer, as we all know, requires smart devices. Smart devices which can be installed and give you real-time values, real-time monitoring of pressure monitoring, gas accumulation rate, and all such. Artificial intelligence is something that we have tried our hand at, and Power Grid is very proud to say that we are one of the first utility to have implemented successfully the artificial intelligence based monitoring of our transformer. Here you can see a DGA is being captured at various intervals. So based on those raw data, a clean and resampled data is calculated by the software automatically. Model is trained on the pattern of the gases based on loading, based on other parameters, temperature, etc. And it is able to forecast what is going to be the DJ value over the next 6 months. So this artificial intelligence would be very useful in predicting on what equipment is most likely going to need my attention in the near future. Power Grid has also implemented a digital AM framework where inputs from our NTMC, ERP and physical transmission system are, along with the real-time inspection through robot and drones, is being considered into this OT, IT and IoT integration, where weather forecast is also taken into consideration. And a standard asset performance management platform is being developed where everything is being taken into picture, everything is being taken into consideration, and we are able to make data analytics, and output is being analyzed based on these values, and we are able to predict what is going to happen next. So this is just an overview of a digital AM framework which we are going to implement. It would also include real-time chatbots where even a person sitting at site can directly interact with this software. If he has any query, let us say if there is night time and there is some emergency at the substation and he wants to take some advice, he need not to ring up some expert. Everything is available through this chatbot, which is available 24 into 7. And he can simply type in his query and that chatbot will make some recommendations, and based on that he can take informed decisions. So our digital transformation team is working on this whole project where this digital framework is being implemented. Of course, we'll be also looking after the cybersecurity team aspects, and financial and HR analytics will also be built into this system. So, like Mr. Shinde said, I think the questions are reserved for end session. So, if I am not, or rather, if somebody has any queries right now, we can take it up as per permission of the chair.
Amandeep, can you hear me?
Yes, yes, sir. I can hear you.
Thank you very much for your very enlightening presentation, and it has given an opening to the audience regarding this particular health index, and then how to use or how to make use of various equipments. What is most important? You have covered all that. We will be further deliberating on that. Can we take anybody has any question, or we can answer them later on also. We ourselves we will take later, but Amandeep may not be there. We will have to answer on his behalf. So Amandeep, you can.
No issue, sir. I will be available online if otherwise if there are any queries, then
okay.
I will address them. We can wait for the end of the session too.
Okay. You can also authorize us to answer on your behalf. Suppose we are able to answer the questions, and then we'll come back to you on remaining question which we require your presence very much. Okay.
Okay.
Hello. So after this session, very enlightening session, detailed session on this asset management, I will also be wrapping up in my presentation something on this what Amandeep has said. So meanwhile, now we come to the practical utilization of this health index and practical utilization of tools and techniques on the asset management. So I invite Mr. Ashwini Jain from Adani, and he will cover the effective use of this asset management and health index tool, how the challenges in the maintenance of TT transformers they faced and how they overcome over that. He will cover in that this subject. I had to repeat, or people have understood, I think. So, Mr. Ashwini.
Yeah, thank you, sir. So I am audible, I believe. Hello. Yeah, I believe I am audible now. So we are running the presentation, I believe, if we can put in on the first slide. Yeah, ladies and gentlemen, I would say good afternoon. So it's been a privilege to share the dais with Negi Saab, Rajamani Saab, Patnaik Saab, and there are other industry stalwarts whom we look to, and we have learned so far from them. And this is a short presentation from a utility perspective. which I wish to cover rather from the distribution perspective. So my presentation would be on the maintenance of distribution transformers and what are the challenges and opportunities. Just a brief introduction. I am Ashwini Kumar Jain. I head the diagnostic and maintenance planning of Adani Mumbai distribution. And I've been part of engineering technology for the last 7-8 years. Okay, next slide, please. So this is the flow of my presentation. So distribution transformers, global statistics. So I believe there are manufacturers, OEMs, but just for the benefit of the general audiences. So I have shared few statistics that we would go through. Then distribution transformers, obviously Indian scenario, what is happening in India, how we are moving, and then the challenges, what challenges we as a utility we do face in Indian scenario. And then there's a BIS 1180 that's been revised recently in 2019 as well as in 2021. And what all things are there and what is the utility perspective. Then I would even share a few AML best practices, what we are following and how we are benefited. And obviously then there's a forward path. One slide I have reserved for reliability centered maintenance. What are the principles, what is the architecture. So gentlemen, you can see these slides. So these are the global statistics. The general figures you can go through, but I would say you can look at the picture. So India, China, and the South Asian countries. So these are, I would say, there's a bigger growth in these regions. China is expanding like anything. Just about a week ago, I had gone through an article wherein it's been stated that China, how they are performing in the renewables. So in just 1 year of span, they have added a renewable capacity, which otherwise the USA has built so far. So just like China, even for, you take example of India. So just as our PM, Mr. Modi, so just as he has announced the Suryodaya Yojana, wherein the rooftop solars would be put on 1 crore households. So just imagine what kind of growth we would be seeing. So consumers becoming prosumers. This is a kind of big thing that we would be seeing in near future. Yeah, next slide we can go. Sorry. So Indian scenario you can see. So India is a kind of very promising future for not only for the manufacturers but for utilities as well as for the other agencies also. So the unprecedented growth that we are seeing in the solar sector, you see the generation capacity is increasing like anything, and to meet the generation capacity to I would say complement the generation capacity, you would require a number of distribution transformer, number of distribution capacity that need to be added. So I would say that when we talk about the distribution transformer, there was one point that I would like to take up with manufacturers probably in the next slides when we would be moving forwards. So for distribution, solar transformers, there's a big requirement, but when I would say even distribution transformers you would be needing in near future, so there has to be capacity building across India, and more manufacturers, they have to build their capacity and they have to come forward to cater to the requirement of utilities. So this is the Indian scenario. You can see the generation capacity, how we have fared up to 2023 figures, then April 2023 figures for transmission as well as the distribution transformers figures. So our generation capacity, our transformation capacity, our distribution capacity, it is increasing like anything. One big peculiarity which I want to highlight through this slide is when you see the different grids. So northern grid, western grid, southern grids, there are a number of distribution transformer. and the MVA transformation capacity that you can see. So there's still a kind of disconnect you can see through this slide. So 3 of our grids, I would say, they need to develop themselves, regulators, policymakers, government. They need to put more efforts to strengthen these grids. And obviously when these grids would be strengthened, so there would be a kind of synergy in Indian power sector. Okay, so I have come to slide wherein distribution transformer, the challenges in Indian scenario. So demand versus manufacturing capacity. So the point that I have taken. So I would take an example of even our example. So when we have been putting tenders for distribution transformers, so many manufacturers, they are sometimes reluctant to participate in the tenders, saying that they have overbooked, they have booked order for solar transformers. Distribution transformers, we are facing challenges. Probably some OEMs who are there, they can correlate with me. So this roadblock, obviously we need to see and we need to remove this. Distribution transformer manufacturing capability, this is a big thing that we need to focus. Then there's the standardization and quality. So obviously policymakers and the other agencies, those are working hard, and not even the agencies, even the utilities, they are working hard to make their specifications standards. CA is doing good work. They have been putting many guidelines for manufacturing, even the maintenance. And the one part is the quality. So quality consciousness, this is a big thing. And I think this is more pertinent for the state utilities, because private utilities, if you see, so there's a kind of engagement they do with OEMs, manufacturers. This is quite good. But SEBs, I think they need to develop their engineering and quality team. This is one big focus that even the government need to understand and government need to put focus on. Then the type testing facility. And yeah, obviously, now you have got the manufacturers, you have got the inquiry, you are putting your capex and your transformer is ready. But unless you have done the type testing, you are not supposed to get the transformer. So this is a big challenge. So Indian agencies, just like CPRA, ERDA, other agencies are there. So they need to expand the type testing facilities, because type testing facility, the lead time is quite high. So the whole capex cycle, capitalization cycle, that is completely disturbed. Then aging network versus capex requirement. Obviously, when we are talking about SEBs, private utilities, we all work in the regulatory environment. And in regulatory environment, you know, you have a fixed rate of return. So obviously, when I would say that my network that's been in service for the last 70 years, 80 years, so I need a kind of obsolescence planning and need to put in capex. But obviously in regulatory environment, you can't do all things in a while. So you have to plan. So even the capex and the regulatory environment, so there has to be some kind of consideration that should be given by the state regulatories as well as the central regulatories on this. Then the asset management capabilities through AIML. So I would again give an example of utilities, state utilities, those are quite lagging behind, though they have quite less sensorization on their assets, and I would say the maintenance, even the regular maintenance of the assets is even a challenge for them. And when you are talking about building the capacities in AI and ML, so this is a quite kind of big thing that they would need to look. And when we talk about the agencies, the solution providers, when they come up with the AI and ML solutions, so the kind of problem that we face, what maturity they do have in their AIL and ML modeling. Because somewhere they have started, and if they are not having the complete data repository, a kind of history with them, so obviously this AML model is not going to work. Then obviously sensorization cost. I would take example, one big thing which is quite challenging in perspective of distribution transformer, the kind of sensorization is very less. For transformer, power transformers, the sensorization, you have number of sensors put in, you have number of accessories, you are monitoring it through SCADA, but for distribution transformers, these are kind of chota bhai, jiske paas kuch zyada hai nahi. And even the population that you see with the utilities, even private utilities, there's a huge magnitude of transformers, those need to be looked to maintain. And when we talk about the volume, obviously, you have to maintain the transformers which requires the maintenance as per the urgency. So we would be covering that part in the next slides. But yes, sensorization costs, the feasible solution, the solution provider, they need to come. And obviously, one advantage probably we have with all utilities, those who have done the energy auditing part, we are having energy audit meter that's been put on distribution transformer. So probably if we can tap that data, let it be through what media we do, MDM or what kind of MDAS system we put in place, and we can tap that data and then synchronize it with our maintenance data, that is going to solve the problem. Then obviously skill set of maintenance staff. So just as Rajamani Saab, what he said, my maintenance worries are mitigated if the transformer design is perfect. But obviously there has to be a maintenance, there has to be scheduled maintenance, kind of condition-based maintenance that you have to put in. And if you are not having skilled staff, because skill, that is the diminishing thing in kind of India when we even see our utility. The skill that otherwise the person they were having, it is now diminishing. So this is just a perspective of BIS 1180. We all know BIS has done a good work. They have put in many administrative measures to curb the irregularities and put in the discipline among the suppliers as well as the utility. So all these things, I believe this presentation would be shared. You can go through the even the standards. So the one big thing, obviously, there is the energy efficiency thing that they have put in compliance, the BIS license to manufacture. BIS license to manufacture as well as the efficiency. So energy level they have specified. So now there are 5 energy levels. Now utility, they need to specify in their specification and get the transformer manufactured. Yeah, there's one point I wish to cover, the total owning cost, the total owning cost principle that utility need to give consideration, which Government of India and BE, Bureau of Energy Efficiency, they have been saying. So this is a good thing. So based on the complete life cycle cost, obviously the transformer need to be selected. So this is BIS 1180. This is what I believe table 6, wherein up to 2,500 kVA transformer, the loss levels have been specified. So the energy efficiency level 1 to level 5. I have highlighted the transformer capacity 630 kVA. You can see that in that violet color line. So I would be presenting a kind of data in the next slide. So loss level in this latest revision, loss level 3, it's been recategorized in loss level 2, and accordingly the new loss level for loss level 5 that's been added. So I would say now the efficiency, since there's a technology advancement in the materials as well as on different fronts, so we can see this transition happening. So this is a kind of thing that I want to show especially to my utility friends. So when we see there's a 630 kVA transformer which is having a legacy loss level, okay, and there's a transformer loading and there's a load factor. So based on that, how many loss units in a year I have calculated. So if you can see for legacy loss level, then there's a loss level 3, 4, 5. So there are different loss level figures that you can see. So I would say 630 kVA transformer loss level 3, it is having loss of around 9,800 units per annum. Loss level 4, accordingly the respective figures you can see. My point is, you are reducing losses, but at the same time when you are reducing losses, you are putting more CRGO, more copper, or whatever the, let's say, aluminum you are putting inside the transformer, more material you are putting inside the transformer. So my cost is getting high. So when my cost is getting high, it is hitting my capex. So let's say in past, I was able to replace around 100 transformers, now probably I would be able to replace 70 or 80 transformers. So this is quite a good thing, but my only contention is when you compare the loss level based on the loading, so few insights you can get. You can decide which energy efficiency level is best for your kind of assets which are loaded to, let's say, 40%, 50%, 70% or 80%, and accordingly you can put that in specification. And obviously when I'm putting capex, so what is my return on investment? When you talk about the life cycle costing, you can always calculate that, and based on that you can take your procurement decisions. So when I'm saying I'm putting more material inside the transformer, this is one slide I think which would be quite insightful to manufacturers, OEM as well as the utility. So you see we are dependent on other countries on copper as well as in CRGO. So even this graph purposefully which I am showing to you, it is showing how our copper consumption, our CRGO consumption, etc. it is going up, and how our imports are going up. So when these imports are going up, obviously our net exports are coming down. You all understand the economics. So my imports are very stressed when I am importing CRGO, I am importing copper, electrical grade copper. So probably utilities as well as regulatory agencies, policymakers, they can go through it, they can decide what would be the best efficiency level, which I think, which would not stress my this import cycle and which would give me a proper results. Obviously, when we talk about the Make in India drive. And there is one another insight that I wish to share. This is a data of AML distribution. So you can see what is the loading of my transformer, the population of my transformers. So you can see around 77% of my transformers, those are loaded less than 50 or less than 60%. So when you say, when you do the calculation that I have done in the previous slide for your less than 40% transformers, so what rate of return you would be getting when you are increasing the efficiency level from level 3 to level 5? What kind of investment you are doing and what returns you are getting out of it? Okay, so this is a part of kind of economics as an engineering manager, what I am put into and I'm supposed to do, and this is the kind of condition managed based maintenance what we are doing in AEML. So as you all know that oil type distribution transformer, they require sampling for their condition based maintenance. So we have around 5,200 oil type distribution transformer in our system. And when we decide the sampling methodology, obviously we are not doing sampling of all 100% transformers here in a year. So there's a scoring criteria depending on what is the age. Sorry. So what is the age of a transformer? What is the loading of a transformer? Transformer is outdoor and indoor. Where the transformer has been put? I do have. Yeah, thank you very much. So based on that, we have defined the criteria, and out of that, we are sampling around less than 3,500 transformers in a year. And there's a criteria even when, let's say, in a total list, if the transformer is not coming for sampling for 2 years continuously, so automatically for third year, the transformer would be sampled. So this is kind of scoring method that based on our experience that we have put into, and based on that, even the sampling methodology has been optimized, our sampling cost has been optimized. And obviously, when the sampling has been done and you are equipped with your OST results, so based on that, the filtration or the overhauling that you decide, and when you see the results based on that, so filtration, even the boundary line cases, you can always consider, you can just, if you have the data, if you maintain the OST data in your SAP system, ERP system, or what kind of system you have, so you can always see what kind of deterioration, the rate of deterioration, and based on that even you can further optimize the filtration and the overhauling volume. Oh, sorry. So condition-based maintenance of DT. So we are doing the annual inspection, substation inspection, wherein we are capturing the observation as well as we are taking the measurements and that we are putting into a SAP system. We are doing the trend analysis, and based on the critical abnormalities, we are generating the maintenance notification, and the things are put in place. So this is one another good practice that we are having. We do the duty loading optimization. We do prepare a yearly plan. We address the DTs, those are loaded as per the criteria. So again, the criteria are what is the age of DT, whether it is under warranty, and what kind of forward path that need to be put into. And not only DT, with the allied equipments like LT, ACB even, we put a kind of consideration, and then we prepare a plan for that. So my last slide would be reliability centered. Probably you can go through the slide. So the only principle that it is having, the most critical component of a network that need to be looked on priority, and rest of the things you can put on back burner. So I think probably some of you must have gone through a book, Reliability Centered Maintenance by Mr. Ramesh Gulati. If you have not, so probably it is in the comment domain. You can have the insights by reading that book. So I believe this completes my presentation. Thank you very much.
Thank you, Mr. Ashwin. Your presentation is very appreciable from the point of view that it is from distribution company. We can put a plant, we can put a STATCOM, we can put HVDC, we can put a big system, generation, transmission, but at the end of the day, the performance of the electricity sector is what? Is only when consumer gets the supply, uninterrupted supply. That is the performance. Everything is forgotten. It has no value. Your lift stops when there is no power. So, Mr. Ashwin, from that angle, things are mostly focused on power transformer and subsystems. People do not look at subsystems and distribution network. And it is quite informative that you converted all the technologies of condition monitoring, routine maintenance, condition monitoring, and then tools, software, energy efficiency things available to you, and you are converted into a practical solutions, okay, in your utility by understanding the challenges first, then implementing. So he deserves a round of applause once again for such a good presentation. Now I invite the next speakers. They will be covering on this inverter duty transformer challenges. Actually, this is one area which has come up in for last 4 to 5 years. And they are the very, very vital transformers which are between the DC of the solar system and the AC supply to the grid. So these transformers has its own challenges, and I hope their presentation will be very useful for all of us, because in coming days, coming years, solar power only going to be there everywhere in the house. Even the Prime Minister has announced after the Pran Pratiksha Day in Ayodhya, he announced that there will be incentive. Already circular has come from center. They're giving incentive more than 50% if you put solar rooftop in your home. That is one thing. But that is the rooftop. But similarly, there will be a small 10 megawatt, 5 megawatt plant where the inverter transformer will play a very vital role. So you please go ahead with your presentation.
Thank you, Negi sir. Thank you all of you for giving us this wonderful platform to present our case studies. Basically, I am not going to like this topic is asset management, so I am just giving the presentation, practical the issues which we have faced in the solar system. So I'll not take much time. just I will introduce myself. I am Rajesh Pawar. I am from Tata Power Renewable Energy Limited. This is one of the leading solar industries, where we have more than 3 gigawatt of solar portfolio and 1.4 gigawatt of wind portfolio. And along with me, Rakesh Verma is there. He's working as a head commissioning, and is looking after all the commissioning activities, new projects which are coming in our portfolio. So I'll go in the first case, where I'll just brief you about what is going on in the solar system. So basically, the solar industries is a cost competitive industries, where we don't have a margin of investing more cost or on the asset as well. So here we have gone with the aluminum based transfer IDT. You can say the inverter duty transformer, which is basically used for converting DC side to from the inverter side to the step up the voltages. So for that, the IDT has been used. So these IDTs are basically aluminum winding IDTs and with the aluminum bus bars. So it was just commissioned, and then after 1 month, we found that the condition of IDT, when we have inspected one of the IDT, LV chamber. So this is what the picture which no maintenance person would like to envisage, because with the 1 month of IDT, what is the condition? So that CT got burned, even the insulation got melting, then the bus bar is fully oxidized. So that is how even the bushing got cracked. The CT, some of the transformer got fault because of the bushing got the cracked, and then there is a oil leakage. So within 1 month of commissioning, we found that this is the condition, wherein we don't have any clue what went wrong. And then in that subsequent investigation, we found the many things, many learnings which we have come across. And then there is a big, you can say, pressure on us to restore this transformer, because as you know, the sun is our fuel, because in solar industry, sun is the fuel, and to have to capture more and more radiation with the grace of sun god, so we need to attend this as quickly as possible. So first of all, we need to find out what is the root cause of these issues. So for that reason, we have drilled down. So this is the cable, you can say the cable are melted. This is aluminum cable, and then all the insulations got melted. Even some part the insulation got exposed also because of the heats. So there is a lot of heats. The temperatures are going beyond 200 degrees Celsius, which has to be below 100 degrees. But there we are finding clueless situations where we cannot load this transformer beyond the 70%, or we have restricted that one. So we are losing the generation. So what is the reason? So that part my colleague Rakesh will going on. So these are the number of transformer where we found the issues. So out of you can say the 100%, if the capacity, you can say the 70% capacity was out because of the heating issues, and which leads to like a dangerous conditions as a O&M point of view. So Rakesh will continue the investigation part.
Thank you, Rajesh. It takes us almost 20 days to resolve all these issues. If I say there were total 18 number of transformers of capacity 12.5 megawatt. So after investigation, lot of brainstorming, we found a lot of problem inside the transformer, starting from its design, its engineering, then workmanship from project side as well as from OEM side. So if we can see, first of all, I will cover one by issue what we analyze one by one. I will try to cover faster because we have time pressure. So first issue, what we found that the design of bus bar, OEM use earlier they done some calculation, they fix some size of bus bar, then they later stage they add one more bus bar. Because of that, it becomes a very thicker section. They add one more bus bar, one more flexible jumper. So because of that, we were not able to tight it properly, and because of that, resistance increases. Of course, there is a current of almost 3000 ampere at 660 volt. So that was one of the heat source. Another big problem what we found, it was a selection of type of lug. So type of lug was not appropriate as per IS design for XLP cable. It was selected some wrong lug from our engineering side. So that was another heat source. Third problem, we found that this transformer, mainly these three problems were there. Third problem, we found that this transformer was exposed to air and maybe some rainy season during the erection and commissioning. So a lot of dust and moisture accommodated there. Because of that, production of aluminum oxide. We all know that as compared to copper oxide, aluminum oxide is very bad conductor of electricity. That become another source of heat. One by one, we eliminate all the sources. First, what we done, we changes the lugs, all the lugs. Still, temperature was going to 200 degrees Celsius. Then we clean all the system, we remove all the jumper outside, then change the nut bolts. Then temperature was reduced to near to 155 degree, 50 degrees Celsius. Another stage, what we done, we with the help of OEM, we changed the bus bar. We reduced the number of jumpers. Of course, this cross section was increased as compared to earlier, and reduced the number of jumper. Also, we increased the size of the tightening nut bolt to the jumper side. Earlier it was M14, then we used later on M16 nut bolt. Then this problem almost got solved. So almost there was 2 to 3 source heat were transferring from lug side to jumper side, jumper to. We were very confused whether this problem is on lug side, this problem is on jumper side. So there were 2-3 problems which was circulating the heat all around. And then one more observation on typical observation on lug side was they have used GI nut bolts. So if we see that what GI nut bolts were getting red hot, maybe more adherent or better ferromagnetic material. Later on, when we replaced these GI nut bolt with SS, then it was lesser temperature was there. So then one of the conclusion was that also. So we replaced all cable set GI nut bolts with SS steel nut bolts. All these things what we have explained, we will find in next slides also. One more improvement what we have done, we introduced some electrical contact grease in between lugs and between bus bars and jumpers. M3 company. It was appropriate for 250 degrees Celsius and improve the electric conductivity, as well as it will avoid the oxidation of the aluminum part. So this what was our, we faced a lot of problem, almost sleepless nights for almost 18 days. These all, oh sorry. If you see one by one, this is the how we analyze the lugs, and then crimping. Even crimping was, workmanship of crimping was not appropriate. Later on we developed a standard procedure for crimping also. This is the lug what we changed from smaller lug to larger, of course as per engineering reports and some IS studies. This is the procedure, standard procedure what we made for lug crimping. Now this we have implemented all cross sides. These are some theoretical calculation for thermal conductivity of older lug as compared to new lugs. Similar for bus bar also. And this is the design change in bus bar. Earlier there were 3 flexible jumper, 2 bus bars. Later on we reduced it to 1 bus bar and 2 flexible jumpers, so that area of contact and we can tight it better. This is the cleaning. Actually there were a lot of dirt and rust was there. So that was also causing the heat. And later on, we were not sure, because one more information I like to give. This is the first time we were using the aluminum winding transformer. That was not new, but this was the first time at this location aluminum bus bar was used. Maximum OEMs are supplying at this location current collector is copper bus bar, but this was the first time we used the aluminum bus bar. Because of that, we were not sure that whether it will sustain in summer season or not. For that, we also installed the temperature sensors in LV ducts. But later on, we found no problem. You can see before and after photos. And this is the situation. These temperature are actual temperature of the site. Actually, how we have taken we load the transformer to full load, say 1 hour, then immediately we shut down the transformer and open it. It may take 20 to 30 minutes, and after that this was the temperature. This is captured to 30, it may be to 50 at that peak. This is the after photographs, after doing all these modifications. The conclusion is, while using the aluminum items, we should be very particular for quality, execution quality, engineering, design, all those things. One more thing, there is a lot of time and cost pressure. So our engineering team, maybe in other companies also. So to do it faster, engineering teams are not involving site teams and one teams in engineering and drawing approvals. One recommendation was we should involve site team also. Then proper spacing of cities. Then was because city was very near to bus. And then one recommendation was, it is better if you, at this place, at current collection where it is better if we can use copper material, but because of cost, if we are using aluminum material, so we have to care a lot of engineering and quality. That's it from my side. And for next item, Mr. Rajesh will come.
So this is a next case study. It's like you must be surprised.
Can
what
I
is
ask
there.
one question, if you permit, to him? One question, just one question. Regarding his overheating of the conductor, I think it's my assumption maybe, but these kind of overheating on the conductors and maybe inside the winding is happening because the system harmonic is getting generated 30 to 40%, and that study is very much required to further control this damage. That is my submission. That's all. Thank
That
you.
study we are doing, there were first we have done that was within the limits. It was done.
But it has to be done in a way it is there, so that is why you are having this
Yeah, I
problem.
will discuss with you.
Yeah.
Hello. Okay, madam, generally in inverter to transform inverter itself, that harmonics you are talking, they very well keep it below 3%. So that is, you are talking harmonics could be reason, but I think inverters are highly sophisticated equipment which takes care of this harmonics.
Harmonic
but we
studies-
cannot rule out the possibility what you said.
Yeah, harmonic studies we are doing. There is a PQ emitter is also installed. So we are monitoring on the regular basis. So as per the CA guidelines, we have to submit the report on a yearly basis. So, and before also we have to, when we are taking the connectivity, we have to submit that report. So that all we have taken care. So there is no issue with the harmonics, but okay, we will discuss. So next case study is regarding the IDT trips on Bookers. So you must be surprised why this is used as a case studies, because this is a normal, you can say, the operation, but there are a lot of learnings from this, and we learn a lot from this, and that's why we want to share this. So initially the IDT was tripped on.
How much time you will take? Because your time is over.
Four slide, I think. Four slide.
Okay, very good. Please.
I will do first. So because it is stripped on bucals and there is no other differential protection is operated, or some kind of overcurrent also not operated. So and there is a gas trap on inside the bucals. So as the renewable the plant was at remote range, so to analyze the DGA, it required almost 2 to 3 days to take the samples and then to then get the result. So we don't want to lose that part. So we try to done that with the olden method, raw method of gas burning method. So precaution is we have to be cautious that if there is some kind of gases like methane, ethanes are there, then it may burn. The flame is got higher, you can say, the elevation. So for that reason, we took the precaution and we tried to burn the gas with the bucals. So I'll just share if. So this is what the method we have tried. We tried to burn that gas, and then the flame was normal flame, and then we conclude that there is no, as such, there is no problem with the transformer, and the gas was normal. So we have tested the transformer also with all the protections, all the required testings, and no abnormalities found, and only the issues was the with the you can say the Megger value, the IR value was low. The PI is healthy, but IR was low, so that we can be done with the filtration that way. So these are some of the raw method where we can analyze the gas. So first is hydrogen. So for hydrogen, the hydrogen will you can say they burn with the blue flame, and then subsequently the other gases will how it will burn, and then what kind of the remarks or what kind of the explosion or what kind of the you can say the flames it will give. So that kind of analysis we have done, and then further we drill down that there is no transformer, there is no issue with the transformer. But then why the bucals are stripped? There is a gas trapped inside the bucals, so that is one of the questions which we are trying to try to get. So for that reason, we analyze the breathing operation of the transformer. So as you know, the transformer breathe, and inverter transformer, as the loads are in the daytime, it is on the higher side, like it is almost a full load, and they are in the night, it is a zero load, you can say. So there is always a huge amount of pressure on the breathing devices, like the breathing. When the load is high, the transformer expel the air outside the breather, and then when the night time it will inhale the air. So breather is the most you can say the important part in the IDTs or inverter duty transfers. So when we inspected the breather, the left side, right hand side breather, if you see, it is the color was very dull, and there is a oil ingress and then dust ingress of inside the breather. So and then when we open the breather, we found that the jelly-like substance which will choke the breathing. So what had exactly happened at that day? So when breather got choked, the transformer could not breathe, and then the entire pressure was on the air cell, which gets pressurized during the daytime, and during the night time when the load got reduced, the entire pressure was on the oil which is coming from the conservator to the main tank. But then what is the cause of the gas which is inside the bucals which we have found? So for that reason, we need to understand the principle of NIPS operation. There is a TCIV valve, which is, everybody knows that the TCIV valve is to isolate the oil from the the conservator tank to main tank. So when in the night time, when the air cell got pressurized, and the night time when the pressure was released, the oil flow from the conservator to main tank got increased, and which has led to operation of TCIV, and which further drill down, further cut off the oil supply from the conservator to main tank, and that has created vacuum inside the transformer, and which leads to a bucals operation. So that's how we come to the conclusion that why Buchholz has operated, and then there is a vacuum inside the main tank, which leads to a Buchholz operation. So we further what we did, we replaced the granular type bushing, granular type silica gel with the crystal type silica gel. See, how the breathing takes place. When there is a gap between the crystals, the air get you can say they crushed or friction. There is a friction between the silica gel and the air, and then that friction will the silica gel will absorb that moisture from the air, and then the dry air will go into the transformer. So that is how. But in the granular type silica gel with the tiny granules, the passage in between the granules are very less, and which are causing the blocking or choking of the breathing actions. So that's why we have replaced this with the higher crystal, granular crystal, higher crystalline silica gel, and which has almost resolved that issue, because we found these issues in the 3-4 transformers, and then we replaced all the silica gel, granular silica gel, tiny silica gel with the crystalline silica gel. So these are the results, and then we concluded that the problem is with the silica gel, and there is no issue with the transformer. My third case study was the IDT HT box flashover, so which is a perennial issues in the solar, as daytime the solar generations are. Thank you. So daytime the solar generation is high, so in the HT compartment you will find the high temperature, and then the moisture get evaporated on the condense in evaporated, and it get condensed over the top of the EVA. So major fault which we found that the support bushings are getting flashed over because of the moisture ingress on the surface of the bushing, and the flashover is external flashover. When we clean the bushing and then we again measure, the bushing was intact, there was no issue. So initially we tried with the resin spray around the bushing, but it could not suppress, because it is just temporary arrangement. So to mitigate these issues, we have gone for the silicone RTV coating inside the ST box, and it has results in like 99% I can claim, because there is no flashover after the silicone coating has been done. So this is a good maintenance practice which we have followed, and then we have resolved almost, now we have completed this silicone coating in almost all sites, where and the issues of flashover inside the HT box are got reduced by with a huge margin, you can say. I don't have that data right now, but there is no tripping as such because of the flashover inside the HT panel. So thank you very much. And
Hello. What is the location? Hello. Excuse me. What is the location of this? What you explained last one.
last one.
Is it coastal area?
So it's a Rajasthan area.
Rajasthan. Okay.
Yeah.
Actually, it quite the solar system. Okay. Panels are to be cleaned is one part. Then evacuation. In evacuation, actually, we have to take a lot of care once it comes to solar, because they are mostly located in the this desert area, or they are located in coastal area. So I think the good experience, I will explain that how O&M, how O&M is now playing a major role, giving a feedback to designer to learn things, and designer also should take a lot of care. After seeing your presentation, I think those cares were not envisaged.
Right.
Those challenges were not envisaged. Okay, so like that, using this porcelain, then you convert into polymer and all that, and similarly cable type and all that. So it called O&M is a very important aspect which gives a feedback to the designer. So any more question for him?
Sir, one problem in solar
so I
is
think, hello, excuse me, quickly finish because people are waiting for lunch.
one problem in solar is in daytime it is full load. In daytime it is full load, and in night time there is no load because of that condensation very high.
Correct, correct. That is what I'm telling. The location, weather condition, climate makes lot of difference in design. We are seeing in our Nalia area in Gujarat that conductors are snapping. But there is another theory. So that is what I'm telling. The change of weather, daytime it is 35, 40, and in the morning it is 5 in the night. So
Yes,
in those
the
situations
same
are to be
condition is
considered.
there in
Okay.
Rajasthan.
Yes,
So,
yes.
and it is a foggy also. So
Foggy
there is-
also, correct.
That is the issue. Yeah. Thank you. Anyone has any questions? Yes. Okay. Okay. Thank you, sir. Thank you for the.
So thank you, Mr. Rajesh Pawar and Rakesh from Tata Power. Okay, I think I will have to quickly finish because people are waiting for lunch. But nevertheless, I'll try to wrap up what Amandeep said about the asset management. Actually, this O&M department has now converted into a asset management department, practically in all the utilities. Because O&M department now we have seen over a period of time, it cannot be looked in isolation. Actually, they are the people who are the nerve of the entire system, who know, the O&M people know what is going on in the grid and what should be done. They are the victim of design and everything. So that's why all the utilities converted this O&M department to asset management. I hope all of you must be following in the same concept in your utility, and O&M also, the OEMs also must work in that direction for looking at the asset management point of view. And if you really see this, what is the ultimate aim of this utilities? Its aim is to get the design life of the equipment, that is one. Second, to have a availability factor of 100%, okay. Practically minus O&M time, of course. So looking into that, this whole thing became a fulcrum, and then thereafter routine maintenance, then it gone to preventive, then predictive maintenance, and then finally it is slowly going into the RCB, reliable center-based maintenance, and whereby we analyze the data over a period of time, and then do not do maintenance, predictive maintenance again and again on the same equipment if performance is okay. So that is all health index covers that. And then apart from that, what Amandeep, everybody said, O&M, this actually gives a feedback to the design department to carry out the change. Many examples have been discussed here in this, like RIP bushing is also outcome of one of the asset management health index victimization. Then this product improvement, then from the safety point of view also, particularly in DISCOM, this asset management takes important, the way you maintain, the way you do the health index, and then you retire the equipment so that it doesn't fail and avoid the catastrophe. So for that purpose also, this asset management from safety point of view, I think utility should measure the safety index also of that utility based on the asset management practices adopted. Then a very important aspect of asset management takes care of the keeping the stock of the spares. Very, very important. I have seen utilities now, of course, after the realization, utilities have been operating since independence, and somewhere in around 2000, people realized that unnecessary spares are being kept. They are gone, but they are buried actually in the utility, and crores of rupees are wasted. But now people are alert. They keep spare only what is required based on the maintenance practices and all that. And all the old spares were utilized, and whatever has gone waste. But in future, we all should avoid. And asset management takes care of this particular part. So one should look at asset management as a whole, O&M as a whole, that you keep these spares to the optimal level. Then this is a very important aspect of the asset management is the system study, O&M performances. Based on that, this CapEx, capital investment is decided. Nowadays, capital investment, earlier used to be, okay, this is required, put it there, that is it. Today, it is not the thing. It is only based on the operational experience, O&M feedback of the asset management, that you will decide the capital investment, capex on capital investment. So these are all the actually benefit of the asset management as a whole. And what are the tools? Tools is one major tool is the system study. Second major tool is the health index. I would like to tell you about this health index here. That please go to next slide. Okay, so just I will repeat this. You mark each and every word in this health index, which I try to define that. Health index of the transformer fleet is a numerical value that summarizes the health condition of each transformer like a human body. Checkup through the weightage allocated based on the present individual transformer condition, monitoring safe operating values, aging process, operating environment, and test results, etc. And thereafter guide us in corrective action for longevity of the transformer till its design life. So I think each and every aspect is covered here to take care. The health index is very important tool available to all the utilities. And now to apply this tool, first of all, objective I already explained. To apply this, first thing is knowledge. The infrastructure is in knowledge bank. So all of you cannot do any health index understanding, do it unless you have a clear knowledge of the each and every parameters what is taken in the weightage of the parameters. So first is the knowledge management, then of course IT tools and software which will churn. Go to next slide. Go to next slide. I think I have covered this. Next slide. Yes, I want to just explain you here that when I said this knowledge bank, and knowledge is very important if you want to move forward, if you want to take a decision. One is important as well, people have heard about DGA. Okay, in DGA, all these gases names are here. You have been explained yesterday that which gas gives you what indication to you, hydrogen for PD, C2H2 for arcing, and then all other gases for the up to C2H6, it is for the high intensity heat hotspot available there in the inside transformer. CO and CO2 for the sludge content. Okay, over a period of time it is for the sludge content to find out if the CO and CO2 value is increasing. Now, I have written the top 10 years old transformer. Actually 10 or 15 years. You have to decide. You have to give it. It cannot be a same table applicable for all the transformers. For new transformer which having age of 1 to 5 years, will have one weightage trend. When the transformer becomes old, I think it's 10. You can read at 15 also. So when you are 15 years old, your weightage trend of the transformer. The parameters and the given here will vary for a transformer which is more than 15 years old, because by that time there could be a change in the oil characteristics, moisture content, which will affect the characteristics of when I talk means resistivity, then tan delta of the oil and the IFT, all these things, KOH, all this will vary for the age transformer very well, and you will have to take a decision based on the characteristics after 15 years or 20 years whether I should change the oil or not. Okay. So these are the DJ parameters, so you should have a clear understanding of DJ study. So you can give a weightage. So you suppose you give a new transformer, you give a weightage of 20%. I give a total because it's very important parameter, so you give a weightage of 20%. Now, when developing a software and developing a tool, you will see that you will rate the combination based on the Rocker method or based on the dual triangle. So you will give the churning of these gases. You will inbuild the formula in the software which will give you a condition of the transformer. Next, SFRA, if it is a new transformer, you give value of the transformer. I will not give it much high value for weightage, 5%. But if you have shifted the transformer, then I will, for that movement, I will give you it more value. Okay, so it is a weightage you will give. Then this winding tan delta, you will give, you will have to give a weightage like a DGA. So you will give it a 10% maybe. It all, actually I wanted to do this exercise, we have positive time. We wanted your feedback, your understanding of the subject, what weightage you want to give. Then pushing tan delta, so we'll give 20% weightage because everybody, transformer failure is very high. So this weightage, when you decide on the weightage, there are certain criteria, I say age of the transformer, location of the transformer, and then the technology of the adopted, what is the design adopted, where it is located, and all that will, they will be behind your mind to give the weightage, okay. But once you are given weightage, okay, then next year, you will give a lesser rating if there is a deterioration in the value. Okay, suppose you are given DG at 20 today as transformer, the next year you will find there is an increase in the gases to some level. So automatically the weightage will reduce. It will come to 18 or maybe 15, depending on the software tools where when the gases are entered, it will churn out automatically and give you the value. Then oil data I have explained, BDV, PPM, KOH, IFT, resistivity, they are all important for the replacement of the oil. So after 15 years service, they become very important. So you give weightage in the beginning, and if you are doing exercise today and you have a 15-year-old transformer, probably give more weightage to this. You can give 20 to here, you can give less value to bushing on DGA. That depends upon you. Then polarization index, this is very, very important. And you will all have to understand the reference value here. I have not, this table was created for reference value, that like tan delta is 0.7, then PI between 1.5 and 2. So you can give value. So your transformer is standing at 2 PI value, and next year or after 3-4 years when you are doing, suppose it has come down to 1.7. So automatically software will give a lesser weightage to that. So this is the way health indexing is done. Then furfural content, furon, lot of explanation was given. It is only also for the purpose of insulation conditions. So this old transformer is very, very important. Then partial discharge, you give value to that. Then radiator leakage, okay, because the radiator leakage is one which is affecting your cooling and which is also a moisture ingress area. So you give value to that, okay. Then transformer loading and location. So this you give some weightage. So this is also an indication. There will be many more things. So based on that, you have to decide. So at the end of the day, I want to tell you that this health indexing is the most powerful tool, and it will help you to understand. You can sense like your own house, like your own health of the human body. You will come to know, okay, you will breathe with your transformers, I will say, life, day-to-day life. So as long as you are very clear on health index, it will give a confidence to you. It will avoid the failure. It will give an indication to us, let us retire the transformer. If somebody is 35 years old and there is nothing to take pride on this transformer is working for last 35 years. You feel that, yes, it has lived its life, it is giving you return. You can buy a new transformer with that. What is wrong in that? So this is all a interpretation, decision making. With this I conclude, and question answer we can take now, or okay. So all of you keep your questions with you, particularly all asset management health index, because this is the next next step, next knowledgeable area, next transformer care area for all of us. Thank you. So I think all the knowledge summarization and his key viewpoint, I invite Mr. Patan Shetty.
Good noon, everybody. I would like to cover on a topic called remaining life assessment. Yeah, in fact, various aspects have been covered. Dr. Rajamani rightly put it in a very simple 4 points. That is, keep it clean, keep it dry, keep it cool, and maintain properly. Then the life will be enhanced. Next slide, please. So degradation is a universal phenomenon, and there are various parameters which will be increasing or decreasing that. So we have to look for what are the parameters we can control, and to what extent we can control will decide the ultimate life of the equipment, particularly transformer being a very precious power system component. So that way we will be looking into the life, as aptly put it in Indian mythology or Indian philosophy, Jatasya Maranam Dhruvam. Whatever has taken birth has to go back. So that way everything goes back, but ultimately we have to see how best we can have the good functional life there, functional service life there. So in the transformer we have metallic components like conductor, core, container, support systems, and the fastener systems, bolts and nuts and other things. We have another component which is liquid, which is highly sensitive and easily susceptible for the contamination there. So that way moisture, dust particles and the polar impurities, whenever the degradation starts, we get polar components entering into the system like carboxylic acids, sulfurous acids. These will be etching away the metal parts and degrading the values of the tan delta, that is tan delta will be increasing, resistivity will be decreasing. So that way these are the components which will be affecting, and we have to take remedial actions at the appropriate period by filtration or online filtration, by removing the moisture, by removing the polar impurities that are possible. Then we have solid insulation, which ultimately will decide the life of the transformer. In fact, we have to categorize something like accidental death is different from the normal aging death. That is, due to the overage, one person dies. That is quite natural. Whereas if accidents happen, or if a particular component fails, say a winding fails, a bushing fails, so these aspects will be something like abnormal, and these have to be taken care by the O&M engineer, and before the catastrophic failure occurs, we have to take the remedial steps so that we can avoid the failure and the accompanied losses there. Next slide, please. So basically, it is the thermal energy which creates many faults there. Whenever higher temperature is there, as many of the authors prior to me were telling about the higher temperature. For example, in Rajasthan, in Delhi region, in the summer, we can approach almost up to 50 degrees centigrade. And as the earlier authors were telling, every 5 degrees or 6 degrees rise in temperature will reduce the service life of the component by half. So that way, temperature is the major system. That's why I appreciate that coolness part of that parameter. You have to keep the equipment cool. Then we have the acidic components which are entering from the paper as well as oil. These have to be controlled. And end of life, we have to think about before, so that we can avoid the catastrophic failure and the accompanied non-availability of the equipment in line. So that way we have to plan for the equipment and its replacement in a systematic way, so that we can have, we should not have any disruption in the line. Next slide, please. So major aspect is degradation. In case of oil degrades, creates the acidic components there and volatile components there. Volatile components are causing the fire hazard risk. They can create fires in the transformer. So those have to be controlled, and of course control is by cooling the system in a proper way. And sludges can cause deposition there, and they can cause permanent damage of the system there by causing major sludge depositions over the sensitive components there. Next, please. Now, the next important aspect is solid insulation. In fact, all these are having major impact, and solid insulation will be having the major system damage there. Whatever damage occurs to solid insulation is permanent damage, and if it is degrading to a level where we cannot further sustain the functional continuity, this component will be affecting it in a major way, and we have to give higher weightage for that. So that way it is better to see how much moisture has entered into the insulation. Retented moisture monitoring is very, very important. So how much moisture is there, and moisture and cellulose will be reacting to form the degradation aspects, thereby the partial discharge initiates and then continues throughout its service life. So we have to see at a stage how and why we have to stop the use of that transformer, and it has to be done in a systematic way by having the empirical relation between all these condition monitoring techniques that we have adopted, right from the tan delta, moisture levels, the DCA analysis, then the perfurol content analysis. All these will become very, very important. Next slide, please. So, all these aspects, next slide, please. All these aspects we are looking in a very different way, because in USA, in the year something like 1994, they started assessing the solid insulation condition assessment in a different way. And almost in the year 2000, we started this testing in CPRI for condition assessment of the solid insulation. And the solid insulation is majorly we are looking for the electrical insulating paper. And this paper is made up of cellulosic material, which is natural polymer. And normally, what are polymers? Polymers are the chain-like materials which are having repeating units there. And here, in the cellulose, it is the glucose units which are connected one to another by glycosidic linkages, and almost something like 1000 to 1500 units will be repeating in a given molecule there. And whenever the degradation occurs, the polymeric chain breaks down and it becomes brittle over the age. For example, you might be observing that if you are taking any old books kept in our house, when you touch the corner comes to your hand. That means the mechanical or the strength of that material will be decreasing. And when the degree of polymerization, which is about 1200 units in a glucose molecule, if it comes down to something like 750, the mechanical integrity or mechanical strength of that material will be reducing by half, which renders the insulation incompatible to create a insulation between the conducting parts there. So thereby we can assess that the end of service life of the transformer has come, and we have to take a decision that we have to discontinue this transformer. So that way this test becomes important. That's why we have taken a step that let us see what is this perfurol content test, which is going to be used by all the utilities, and we have to understand what is that. Next slide, please. So here, paper almost contains 89% of the cellulosic material. When it degrades, the polymer chains will be breaking down, and it will be generating the degradation products like perfurols or the furans there. It's a heterocyclic organic material. Next, please. Yeah. So this is a cellulosic molecular structure, and perfurol content is a heterocyclic system where oxygen is in one of the corner. Heterocyclic means the carbon materials are called as aromatic compounds. If you are having oxygen or nitrogen, they will be called as heterocyclic materials. If oxygen is there, they are called furans. If nitrogen is called, it is pyrols. So that way, the naming is there. And perfurol content is an important degradation product which can be measured very accurately by a system called high performance liquid chromatograph. Just like gas chromatograph, where the gases are separated and quantified, Here, the liquid components can be separated. In fact, this technique is used for the even biological analysis, whether it is DNAs, hormones, proteins, we can separate and quantify it. So like that, in the electrical engineering, we are using this for finding out how much the cellulose has degraded. Next slide, please. So, degree of polymerization can be measured by taking the paper out. Earlier, prior to 2000, we used to take out the paper and trying to analyze what is the mechanical strength of that, what is the degree of polymerization of that. But this becomes an intrusive technique. We are going to disturb some of the insulation. So, this is also being done to have a comparative check whenever the situation is too worse there. Next slide. So, this is the instrument called as high performance liquid chromatograph, where the liquid components are separated. It uses a detector called as photodiode array detectors. Next please. Here we are detecting the components to the level of parts per billion. In case of the gas chromatograph, we are going for the parts per million level. Next please. So this is the type of chromatograms we are getting there. At two different wavelengths, we will be measuring what are the absorbances, and then we detect what is the furan content in that given oil. Next please. This is absorption at another wavelength, 220 nanometers. Next please. So here are the limiting values that we have arrived at for the Indian conditions. Please note that ours is a tropical country. Our ambient conditions are entirely different from the European countries. Say for example, 20 degrees is their ambient condition, whereas we can go right from 20 degrees to 45 degrees. So that way, our electrical equipment will be facing much higher thermal stress. Our degradation levels will be much higher. So we have to look into these aspects in a careful way and decide what will be our limiting values as compared to the Europeans. So that way, we have decided that if the ppb levels are less than 100, it's a normal transformer and its insulation is perfectly healthy. 250 to 1000, that means the degradation has started. That means moisture has permanently entered into the system and started the degradation. And it is not going out due to the thermal cycles the equipment is undertaking there. And if the values are more than 1000, then the transformer is highly unreliable. And if it is greater than 2500, transformer can fail any time. So that way, we can have the assessment and take the remedial or replacement actions so that we can have the transformer in line without allowing the transformer to go for the catastrophic failure. Next slide. So this technique is an indirect technique. It is not intrusive, and along with the dissolved gas analysis, we can do this by testing the oil only. So that way, we get a very reliable, accurate information and assess the condition of the solid insulation without having any extra effort. Whatever the oil samples are coming, we can use this for this testing also. So that way, I appreciate the leading organization of our country, that is Power Grid Corporation of India, which is using perfurol content and other techniques in a systematic manner by using a software. And here, I am also requesting all other utilities to have a data bank, compile all the data and have their own artificial intelligence assessment techniques where the faults can be assessed, remedial action can be concluded by using the softwares. In fact, along with the other professionals in the country, we are planning to have such database and even interpretation techniques made available in a group there. So, next slide, please.
Sir, you have to quickly finish. People are waiting for lunch.
Yeah, I'm just taking. Yeah. Yes, sir. I will take only 1 minute. So these are the different correlations available in the degree of polymerization as well as perfurol content. Various formulas are derived. In fact, for our country, we have a separate this one because our ambient conditions are different. We cannot use European formulas there. Next, please. So these are the different experiences in China and other countries. We have to compare and see how they are assessing the soil. So that way, remaining life assessment, we are doing it by perfurol content, which is a very good test. I request all of you to use this test as a supplementary test to the other condition assessment techniques. Thank you so much. Thank you.
Hello. Thank you, sir. And then what is next? I think we have to conclude, or we have time to raise questions.
Sir, we will take a break for lunch now.
Excuse me.
Yeah. Just give me a moment. Sir.
We have time to raise questions and answer.
Two questions.
Two questions.
Yeah.
Who is the lucky person of two questions? I don't know.
Actually, sir, one small mistake happened in yesterday's correction for this health indexing and asset management. Dr. Aradhana Ray was also part of the panel, but madam, please accept our apologies due to typing error. We missed that, but sorry, just corrected this, and we can take two questions.
I think I will. You are experts, sir. Actually, questions from backside will be preferred.
Yeah, I think what Mr. Negi is saying, let the because you people are already experts, so people from the field. Yeah. Please tell your name.
Yeah, myself Rajesh from Shildis Aeronautics Limited, Kadapa, Andhra Pradesh. Sir, I have seen so many informations about the degradation of cellulose papers what we are using in the transformer industry. So can we find, am I audible, sir? Am I not? So we are using cellulose papers in the transformer industry for so many years. Do we have any alternate so that the degradation of the paper cannot happen? Or I'm thinking that varnish impregnated papers can be used as insulation? Varnish impregnated papers can be used as interlayer insulation.
Actually, I'm not able to understand your question properly, but what I perceive is you are thinking about the use of alternative paper sources for the insulation. Yeah. Yeah. So best available in the country can be used. I think Lakshmanan, Isola and other people are there who are manufacturing electrical grade papers. They are good enough. We can use them. And insulation again is a natural material, and they select particular variety of material which is giving optimum performance. That should be okay. And we are having the synthetic materials now. That is something like polyamides can be used. They call it as something like brand names like Nomex and other materials are coming. Even those can be used. And I have a patent filed in CPRI where we have used material based on the polyether ketone. So this is a high temperature, high performance polymer which is having something like a material added to it which is having the better thermal conductivity. Basically, thermal management is a very important concept there. Whatever heat that is generated has to be siphoned away from the winding. Unfortunately, the paper is an electrical insulation and is also a thermal insulation. So because of that, the heat energy resides in the winding and thereby localizing that and increasing the temperature, increasing the degradation. So that way, the thermal conductivity should be enhanced. So that way, polyether ketones, we have used the additives which are having the better thermal conductivity apart from having the electrical insulation property. So that way it is working well.
Mr. Patansetti sir, we are really running out of time. And gentlemen, your question can be answered by Jason sir because they are using lot many alternates. So please contact him. And yeah.
Yes.
Sir, you have bank of question. It can be kept after 4 o'clock.
सर छोटा सा एक क्वेश्चन है। आज अभी साहब ने बोला कि 5 डिग्री टेम्परेचर बढ़ने से ट्रांसफार्मर की लाइफ आधी हो जाती है। तो मेरा सबको बहुत सारे मैन्युफैक्चरर्स है, कंसल्टेंट है, डिज़ाइनर है, सबको ये क्वेश्चन ऐसा है कि फिर हम क्यों हमारे वर्किंग टेम्परेचर को कम नहीं कर सकते। अगर हम वर्किंग टेम्परेचर को डिज़ाइन में ही कम कर लेंगे तो ट्रांसफार्मर की लाइफ और बढ़ जाएगी, और ये तो कैपिटल कॉस्ट इन्वेस्टमेंट है। तो अगर हमको ये मालूम है कि 5 डिग्री घटाने से उसकी लाइफ डबल हो सकती है, तो फिर हम ऐसा क्यों नहीं करते डिज़ाइन के दौरान? हम कॉस्ट के पीछे क्यों भाग रहे हैं? क्योंकि जब प्रोजेक्ट में कोट करना आता है तो सब लोग बोलते हैं नहीं L1 लाना।
सर क्वेश्चन
तो ये मेरा एक क्वेश्चन था कि हम ये उसको क्यों एकोमोडेट नहीं कर रहे? 5 डिग्री कम, भाई वर्किंग टेम्परेचर ही 5 डिग्री कम कर दो।
मैं आपसे बिल्कुल सहमत हूँ। एक्चुअली इन दी something like efficient transformer, star rating and all, actually we are over designing the transformer so that the temperatures will not be going up to that level. So that way हम
नहीं सर, अभी जो नया स्टैंडर्ड है डिस्ट्रीब्यूशन का उसमें ऑलरेडी 10 डिग्री कम किया हुआ है in 1180 part 1, part 2 and part 4. So let's take that later. Now the temperature rise from 55 is reduced to 35 and 45. We take that later.
So it is a challenge.
I suggest now at this moment we stop. I know there is a limit. There is a lot of enthubi, people to ask question. We have to accommodate Dr. Aradhana's PPT and then we have 2 hours question and session. So I declare we stop here. Maybe I request Chairman sir to please present memento to the authors, and we have a group photo. Mementos please. Ms. Ashwini Jain, please. Slow, careful. Mr. Rakesh Verma and Mr. Rajesh Pawar. Adani put really a good practical approach to the available issues. Really good.
Mr. Rajesh Pawar.
Yep. Mr. Rajesh Pawar. And then bouquet to Mr. Patan Shetty, please. May I request Mr. Potnis to be on stage to present bouquet to Negi sir? All right. Sorry, we are putting you in trouble. I know, please. So please all be there. We take a group photo. Mr. Potnis, please be there. Potnis sir, please be here. All right, so let's break for lunch. We will reduce slightly a time on lunch and we should be here by 2:30. That's 35-minute break for lunch. Please be here sharp at 2:30.
There is one good news. Mr. Shrikant Potnis has said that he will not give presentation and he will only take question and answer session on OLTC. Thank you very much.